Hello, my name is Julian Zorro. Next, I will talk about the static subject. The professor each is Hector Dusan. The dynamic principle is mechanical engineers refers to the analysis of systems in motion or subjects to forces that cause changes in their speed or direction. It's a key conceptual foundation in mechanical engineering that is applied in a variety of practical situations. This principle is based on the fundamental law of dynamics, such as Newton's second law, eh, which states that the net force applied to an object is equal to the mass of the object multiplied by its acceleration. In practical terms, the dynamic principle is used to design and analyze mechanical systems, such as machines, vehicles, and structures, taking into account the forces acting of them and how these forces affect their movement and behavior. For example, in the design of an automobile, dynamic principles are applied to calculate the vehicle's drag, accelerations, braking, and stability. Transitional equilibrium refers to the condition in which a system or body that was initially at the rest or in equilibrium begins to experience a change of movement due to the application of external forces or change in environment conditions. In other words, it is the passage from a state of equilibrium to another state that involves movement or change of position due to external influences. The moment of force, also known as tongue, is a measure of the tendency of a force to rotate an object about a specific point or axis. It is calculated by multiplying the magnitude of the applied force by the perpendicular distance from the point of application of the force to the axis of rotation. In simple terms, the moment of force describes the amount of twisting that a force can apply to an object. For example, when you apply force to a door around the hinges to open or close it, you are generating a moment of force. This concept is fundamental in mechanics and engineering to understand how forces affect the rotational movements and objects and systems. The second equilibrium conditions refers to an additional condition that must be met for an object of system to be in equilibrium. This condition is added to the first equilibrium condition, which states that the sum of all forces must be equal to zero for the object to be static equilibrium. The second equilibrium conditions applies specifically to rotational equilibrium, that is, when an object is not only at rest but also not rotating. This condition states that the sum of all moments of force or torque about a point or axis must be equal to zero for the object to be in rotational equilibrium. In summary, the second equilibrium conditions refers to the need for the sum of the moments of force to be zero for an object to be in both static and rotational equilibrium.